In this video, we're going to take a look at our next data structure, which is a queue. So when we were taking a look at stacks, we were looking at something that was last in, first out, or LIFO-based data structure. A queue is sort of a complement to that in the sense that it is FIFO, which means that it is first in, first out. So rather than the last thing being added being the first thing removed, instead the first thing being added is the first thing being removed. And this idea is really similar to the way that a normal queue or lineup works, right? Like if you're in a lineup at the grocery store, the first person in the lineup is the first person to get serviced by the cashier. Everyone else joins at the back of the line. So it really mimics that like real life queue. Now, this idea comes up in a lot of different places in computer science. Oftentimes, we'll have things inside of a queue waiting to be serviced, and we need to service them in some sort of format. And this is where these queue-based data structures are really going to come in nicely for us. So we'll see these pop up in a number of different applications. Much like a stack, there's three main operations that we have with a queue. So that's why I like to cover them generally together, is that they sort of fit the same sort of mold of linear data structure where data is sequential and sort of accessed in a singular way, in this case, first item in, first item out. The three main methods that we have are onQueue, which adds something to the queue. We have dqueue, which removes something from the queue. And then we have peek, which tells us the thing that's at the front of the queue currently. You may see people just call these push and pop. In some cases, people use the same terminology between the two. These are like the formal terminologies, onQueue and dqueue. But you could choose really any sort of terminology to describe these. I'm just using the ones that are most common for textbooks and this sort of idea here. So let's look at an example of this. Say that we have three different values that we want to place on a queue, right? When we first onQueue that first value, it'll be placed onto the queue. And generally what we do is we keep track of two different things in our queue. We keep track of what's currently at the front of the queue and what's currently at the rear of the queue. And when we first start, those two things are the same, right? The front and rear are the same because there's only one value inside of the queue. But when we insert our next value, that's where things start to change. So when we onQueue the value 2, for instance, what happens is 2 will become the new end of the queue or rear of the queue. And it's going to be, 1 that's at the front still. Since 1 was the first thing that was inserted, it remains at the front of the queue. Everything else gets inserted at the rear. And you'll see that as well with 3, right? When we insert 3 to the end of this queue, 3 becomes the new rear of the queue, 2 is the thing that comes next, and then 1 is the thing that is at the front of the queue still. Now when we go and dqueue, remove something from the queue, we remove it from the actual front itself. So in this example here, the value 1 would get removed, and what would happen is 3 would still be at the rear, right? But now that 1 has been removed, 2 becomes the new front. So this data structure becomes fairly interesting because with a stack, we were adding and removing from the same place. But with a queue, we have to be able to add at one place and remove from another place. So we have to keep track of sort of two things at once. So it makes things slightly more complicated, but you'll see that the implementations are really going to be very similar to a stack, and it's not really going to be too much to worry about. So this is a good exercise for moving on to more complex data structures overall, is starting with these really basic ideas of tracking one item, tracking two items, and then we can start to build up that complexity over time. But overall, this is the general idea of the queue. And as I mentioned with the stack, our goal is to get these all as efficient as possible. Preferably constant time would be our goal. And you'll see very interestingly is that because we have to add or remove from different places, the array-based approach for a queue is actually less efficient than the linked-based approach. So in this case, we have a very explicit benefit to having a linked-based approach to a queue. So we'll examine those two approaches in the next two videos. So thanks so much for watching. I'll see you in the next one.